lymphocytes, and other white blood cells. The primary lymphoid organs include the thymus and bone marrow, and the secondary lymphoid organs include the tonsils, lymph nodes, spleen, and mucosa-associated lymphoid tissue, or MALT for short. The spleen is the largest lymphoid organ. It receives blood from the splenic artery and is the only lymphoid organ that primarily filters blood instead of lymph. It's an encapsulated organ that's typically about 12 centimeters in length, 7 centimeters wide, and 3 centimeters deep. The spleen's functional tissue, or parenchyma, consists of red pulp with small white nodules of lymphatic tissue scattered throughout, called the white pulp. Although, when looking at the spleen histologically after it's been stained with H&E, the red pulp is actually stained a combination of pink and purple, and the white pulp is stained dark purple because it contains a large number of basophilic nuclei. If we take a closer look at the outer edge of the spleen, the capsule that surrounds the spleen is seen as a dense layer of pink connective tissue. The connective tissue also forms short extensions into the spleen called trabeculi. The trabeculi will also occasionally surround arteries as they enter the parenchyma of the spleen. These trabecular arteries are branches of the splenic artery. The remainder of the tissue seen in this image is the highly vascular red pulp. Now, if we move to a different region of the spleen, we can see that there are areas that are more basophilic and stain mainly purple. These areas of lymphatic tissue make up the white pulp, which consists mostly of T cells or B cells. The trabecular arteries from the previous image branch even more and become central arterioles. Each central arteriole is surrounded by a periarteriolar lymphoid sheath, or PALS for short, which is a cylindrical mass or sheath of mostly mature T cells that surrounds the central arteriole. At certain points along the central arteriole, the PALS have localized expansion of tissue that form lymphatic nodules of primarily B cells called splenic follicles. The formation of the follicles actually displace the central arteriole, so as a result, central arterioles are not centrally located in splenic follicles. The lymphatic tissue surrounding the central arteriole is still primarily mature T cells, but the rest of the lymphatic nodule consists primarily of B cells. The eosinophilic center of the follicle is the germinal center, which contains activated B cells. Immediately surrounding the germinal center is the mantle zone, which is a dark and more dense circle of B cells and macrophages. And the outermost region that surrounds the mantle zone is called the marginal zone. This zone is not as densely packed and forms a thicker ring of B cells, macrophages, and dendritic cells. Alright, now let's focus on the red pulp, which appears noticeably more eosinophilic, or pink, because of the large amount of red blood cells present. About 70% of the red pulp by volume is composed of the parenchyma, and about 30% consists of the venous sinuses, or sinusoids. The venous sinuses are broad interconnected vascular spaces that are lined with specialized endothelial cells that filter the blood. Defective or abnormally shaped RBCs, such as spherocytes, won't be able to pass between the endothelial cells, and they'll eventually be removed by nearby macrophages. The endothelial cells have large round basophilic nuclei and have reticular or net-like fibers that surround the sinusoids to provide structural support, although they can't be seen with light microscopy alone. The venous sinuses of the red pulp actually looks like cords under the microscope, which is why they're also called cords of Billroth, although if the red pulp was seen in 3 dimensions, it would actually look more like a piece of Swiss cheese with the holes representing the sinusoids and the cheese representing the parenchyma. The parenchyma is a combination of macrophages, lymphocytes, loose connective tissue, arterioles, and